Welcome back dear student and Jai Swaminarayan. In this video, we will discuss the last point of the chapter, that is the power of the lens. Dear student, we know that what are the different types of the lens. There are different types of the lens like concave lens, convex lens, plano-convex lens, plano-concave lens and meniscus lens. So, what is the power of the lens and how we define the power of the lens? So, let us see what do you mean by the power of the lens. So, dear student, we know that the lens converts the rays of the light or the lens diverts the rays of the light. So, if we consider the convex lens converts the rays of the light incident on it, whereas the concave lens diverts the rays of the light incident on it. So dear student, the ability of the lens to converge or diverge the rays of the light depends on its focal length. So dear student, convex lens has a positive focal length and concave lens has a negative focal length, and the ability of a lens to converge or diverge light rays depends on its focal length, right? So dear student, at what amount the rays of the light are converged at a one point, or at what amount the rays of the light are appear to converge from a point, any point, or we can say that the rays of the light are diverted at what amount, that is depends on the focal length of the lens. So the ability of the lens to converge or to diverge the light rays depend on its focal length. For example, a convex lens of a short focal length bends the light ray through a large angle. So, if we consider the convex lens having a very short focal length, that means the focal length of the convex lens is a less. So, the ray of the light bends more, right, with a very large angle, so it get more converted at a one point. So for example, a convex lens has a short focal length, has a less focal length, bends a light rays through a large angle by focusing them closer to the optical center. So dear student, if we take a convex lens with a small focal length, the rays of the light bends towards the optical center with the very large angle. So as the focal length of the convex lens is more, the rays of light are converged at a small angle, and it is very away from the optical center, right? So convex lens of a less focal length, right, the rays of the light converge through a large angle by focusing them closer to the optical center, right? And the convex lens has a large focal length, bends the ray of the light through a small angle by focusing them away from the optical center. So now dear student, similarly, if we take a concave lens of a very short focal length, very small focal length, cause the higher diversion than the ones with the longer focal length. So concave lens of a small focal length, very short focal length, cause the higher diversion. The rays of the diversion are at a very large angle compared to the concave lens with the larger focal length. So convex lens or a concave lens, right? If we take a focal length very small, it will converge or diverge at a very large angle compared to the longer focal length, compared to the larger focal length. So dear student, we can say that the ability of the lens to converge or to diverge depends on its focal length. If the focal length is a large, it will converge at a small angle, and if the focal length is a short, it will converge at a large angle, right? Resulting that the rays of the light are focusing very close to the optical center. So if we considering a focal length small, the conversion is more, and if we considering a focal length large, the conversion or a diversion is a less. So the conversion or a diversion of the lens depends on its focal length. So if the focal length is a short, the conversion of the light rays or the diversion of the light rays are a larger at a larger angle. And if we considering a focal length very large, the conversion of a light rays or a diversion of the light rays are a small at a small angle. So the power of lens is nothing but the ability to converge the light rays. The ability to converge or the diverge the light rays is called the power of the lens, and it depends on the focal length, right? So the power of the lens is defined as the reciprocal of its focal length. The power of lens is defined as the ability of a lens to converge or diverge the light rays, and the ability of the lens to converge or diverge the light rays depends on its focal length. So the power of the lens is defined as the reciprocal of its focal length. If the focal length is more, the power of lens is less, and if the focal length is less, the power of lens is more. So the power of lens is defined as the reciprocal of its focal length. The power of lens is represented by a capital P, right? Letter capital P. The power of lens P is given by the formula P is equal to 1 by F, right? Power of lens is the reciprocal of the focal length. So the formula of the power of lens is a P is equal to 1 by F. So dear student, here the power of lens P is equal to 1 by F. F is more, we get the power less. F is more, we get the power less. Whereas if the F is small, we get the power more. So the power of the lens is the reciprocal of the focal length. So here the focal length is measured in a meter. So the power of lens, the unit of the power of lens is a meter 1 by meter, or we can say that the meter inverse. The SI unit of the power of lens is a diopter, right? What is the SI unit of the power of lens? The SI unit of the power of lens is a diopter, and it is denoted by capital D, right? So dear student, the power of lens is a capital D, and capital D, that means the diopter. Now here, if the focal length is expressed in a meter, 1 diopter, what is the 1 diopter? 1 diopter is the power of the lens whose focal length is a 1 meter. So if we considering a lens having a focal length 1 meter, we can say that the power of that lens is a 1 diopter. So dear student, 1 diopter is equal to 1 meter inverse. So dear student, understand what is the SI unit of the power? The SI unit of the power is a diopter. Power is defined as the reciprocal of the focal length. So from that we get the formula P is equal to 1 by F. So from that the SI unit of the power is a diopter, and it is denoted by capital D, right? If the focal length is expressed in a meter, what is the 1 diopter power? If the power of lens is said to be a 1 diopter, if the lens has a focal length of the 1 meter. If the lens having a focal length of the 1 meter, the power of that lens is a 1 diopter. So we can write like this: 1 diopter is equal to 1 meter inverse. So if the power of lens is a 1 diopter, we can say that the focal length of the lens is a 1 meter. Dear student, here we know that the power of convex lens has a focal length positive, right? Convex lens has a focal length positive. So the power of convex lens is a positive, and concave lens has a focal length negative. So the power of concave lens is a negative. So dear student, the power of convex lens is a positive and power of the concave lens is a negative. Understand what do you mean by the power of the lens, right? So now dear student, when we our eye cannot see the object which is far or near to our eyes, we go to the optician, and optician prescribes a corrective lens indicating their powers, right? Our spec has a some type of the lens the optician provide to us, right? And optician prescribe the corrective lens indicating their power. So if we cannot see the different object near to our eye which are far from our eye, so we have some defect in our eye. So due to this, the optician prescribes the corrective lens indicating their powers. The optician gives us the power of the lens which we require to put in our eye. So let us say that, for example, a lens prescribed has a power equal to the plus 2 diopter. So here the optician given a number plus 2 diopter. So here the power is a plus. That means we require a convex lens, right? So if the optician prescribe us the power equal to the plus 2 diopter, this means that the lens prescribed is a convex lens. The optician prescribe us a convex lens whose focal length of the lens is a plus 0.5 meter, right? So the power of lens is a plus 2 diopter. We have a power of lens is a plus 2 diopter. Positive power, that means the optician prescribe us a convex lens. And how we can calculate the focal length of the convex lens? The focal length is equal to f is equal to 1 by p. From this formula, p is equal to 1 by f is equal to 1 by p. So if you calculate 1 by 2, we get a 0.5 meter. So we require a lens of a convex lens of a focal length 0.5 meter, right? Understand, dear student? If the optician prescribe you as a power plus 2.0 diopter, right? So this means that plus means that the optician prescribe a convex lens. And how we can calculate the focal length? From the previous formula, p is equal to 1 by f, we can easily calculate the focal length of the lens, right? Similarly, if the optician prescribe us sorry, a lens of a power minus 2.5 diopter, minus, that means the optician prescribe a concave lens, right, which has a focal length. How we calculate the focal length? Focal length f is equal to 1 by p. So if you do 1 by 2.5, we get the 0.4. So the lens of a power minus 2.5 diopter has a focal length of a minus 0.40 meter, and the lens is a concave lens. So dear student, understand about the power of the lens, right? And how we can describe the type of the lens and the focal length from the power of the lens, right? If the power of the lens is a positive, we can say that the lens is a convex lens, and if the power of the lens is negative, we can say that the lens is a negative. And from the formula p is equal to 1 by f, we can easily calculate the focal length of the lens. For example, if we consider, find the power of concave lens of a focal length 20 centimeter. Here the power of the concave lens. Dear student, we know that the power of the concave lens is a negative, right? The focal length of the concave lens is a negative. So here the focal length is given to you. Focal length f is equal to 20 centimeter, right? Not a meter. Here are 20 centimeter. But the focal length of the concave lens is a negative. So we write f is equal to minus 20 centimeter. We need to convert this into the meter. 20 centimeter is equal to 0.2 meter. So the focal length of the concave lens is a minus 0.2 meter. So how we calculate the power of lens? The power of lens P is equal to 1 by F, right? So 1 by minus 0.2. We get the power of lens is a minus 5.0 diopter, right? So here the power of lens is a negative. That means that the lens is a concave lens, and from the 1 by f it has a focal length 20 centimeter. So dear student, I hope that you understand the what do you mean by the power of the lens and what is the use of the power of lens. Thank you very much for watching my video.